Hello and welcome to the lesson notes for 1-3 over distance and midpoint. Let's get started. Here's just a quick list of your standards. I'm not going to bother reading all through these. If you want to pause the video, you can read those. But in shorter terms, this is what we're going to be doing today. Previously, you knew how to graph points on the coordinate plane. Now we're going to take a look at finding the distance between those 2 points and finding the midpoint of a segment with those points as endpoints. So here's a vocab you should have already taken down in your vocab notebook, and so you should know what these mean. Distance, irrational number, midpoint, and segment bisector. We'll talk about all those in this lesson. So let's first understand a little bit of the vocabulary. The distance between 2 points is always a positive number. Therefore, it's called the absolute value of that number. The absolute value of the difference of the coordinates. So we'll never get a negative there, so we just subtract and keep the absolute value. That means the distance could also be called the length of the segment. Alright, so if P has a coordinate of x1 on a number line, it just means the first x coordinate. Q has a coordinate x2, then I could write my distance on a number line as the absolute value of that difference. Doesn't matter which order you use because we're using absolute value. Okay, so let's do example 1 together. Let's find the distance between Q and R on the number line. Well, the distance QR, notice we write it like that. I don't have any notation above it. This means a length. If I don't put any notation above it, it means a numeric value like we talked about in the previous lesson. So I could just count 1, 2, 3, 4, 5, or I can use that formula. If I do the absolute value of the difference of the coordinates, let's pick Q, -2 as our first coordinate, minus the coordinate for R, which is 3. That gives me the absolute value of -2 minus 3 is -5. And the absolute value of -5 is +5 because -5 is 5 away from 0 on the number line. Like I said, if we just counted, we get that same value. So that's how you can check. Okay? But it gets a little more complicated whenever we look at the coordinate plane when I have both x's and y's. So this is our distance formula. If the one point we call x1, y1, then the other point is x2, y2. It really doesn't matter which one is which. We're going to subtract the x coordinates and square that number, and subtract the y coordinates and square that number, then add those two squares together and take the square root. Alright, so let me write that formula for you at the top of this page, and let's do these examples. Remember the distance formula, which is very important, you will need that a lot this year, is x2 minus x1 squared plus y2 minus y1 squared, and then I take the square root of that sum. So let's use that example to do part A. The distance between these 2 points, we're going to call -5, 6 our x1, y1, and 8, -4 our x2, y2. It doesn't matter which one's which though, as long as you keep the order the same for the x's and the y's. So I'm going to do 8 minus -5 squared, but 8 minus -5 is the same as 8 plus 5. And then I will do -4 minus 6 squared, and then take the square root. So let's simplify a little bit at a time. These parentheses go first. 8 plus 5 is 13, and -4 minus 6 is -10. But when I square these numbers, I'll get positives for both. 13 squared is 169, -10 squared is 100. So if I add those together, I have 269. I want the square root of that, which is approximately 16.4 when we round to the nearest tenth. We're going to go ahead and round these to the nearest tenth. If it works out to be a perfect square, that's fine. Otherwise, just round to the nearest tenth. Alright, so why don't you take a little bit of time and try and do part B. Go ahead and find the distance using your distance formula. Again, you can call 4, 3 your x1, y1, and -3, -7 your x2, y2. Plug them into this formula and get your answer. Again, round that to the nearest tenth when you get to that point. Alright, if you need more time, go ahead and pause the video. Otherwise, this is what we should get. 12.2 when we round to the nearest tenth. Okay, let's recover what we've done here. We do -3 minus 4, which is -7. When I square that, I get 49. Then I do for the y's, negative 7 minus 3, which is negative 10, square that, and it's 100. So I add those together and get 149. The square root of 149 is about 12.2. Now, you can check this using what we call the Pythagorean theorem. Well, what is the Pythagorean theorem? Hopefully you remember that. Pythagorean theorem is a squared plus b squared equals c squared. A and b are the legs of a right triangle, c is the hypotenuse. Well, we don't see a triangle here, so let's actually plot the points from b and see how that works out so we can check our work. 4, 3, we go over 4, up 3. Negative 3, negative 7, we're going to go back to negative 3 and down to negative 7. And then we're going to use a straight edge to graph that line. And this segment that we are graphing here, if I just stop at those endpoints, is actually the hypotenuse of a right triangle, where the horizontal difference is one leg and the vertical difference is another leg. Since I have a right triangle, the Pythagorean theorem applies. A is this leg. So if I count that, 1, 2, 3, 4, 5, 6, 7, that's where that 7 comes from for the x's. And for the y's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's where we get that 10. So if I take a squared plus b squared, that will equal c squared. Your hypotenuse is the length or the distance between these 2 points. So let's plug them in to check. Say a is 7, b would be 10. We can find c by doing this. 7 squared is 49, 10 squared is 100. That's where our 49 plus 100 comes in, which is 149. And then to solve for c, we take the square root of both sides. Once again, the square root of 149 gives us 12.2. So that's how that works. You could check part A on your own the same way to make sure we've done it right, but it'll always work out that way. What this shows us is that the distance formula comes directly from our Pythagorean theorem in the coordinate plane. Alright, that leads us to be able to talk about midpoint. Notice I've gone ahead and given you the formula for midpoint in the coordinate plane with x's and y's. If you're dealing with only a number line, we just use the x part of this. We just add up the coordinates and divide by 2. You're finding the average of those coordinates. That's what midpoint means. So if it's x's and y's you're using in the coordinate plane, then you find the average of each set of coordinates. So we can find the midpoint pretty easily. Here's what I want you to do. I want you to try and plug these in for a and b, and then we're going to check our answers. The first ordered pair is always going to be x1, y1. The second ordered pair is going to be x2, y2. Try and plug those in, reduce your fractions, and see what you get as a final answer. Alright, here's what we should get. Okay, we get 1/2 10 because negative 4 plus 5 is 1. 1 over 2 is 1/2. You can leave it written that way. 8 plus 12 is 20. 20 divided by 2 is 10. Alright, for part B, we should get negative 3/2, negative 1/2, or we could write that as a mixed number, negative 1/2, negative 1/2. Alright, before we move on to part 5, what we've done here is I've given you both endpoints on example 4, and we found the midpoint. Well, on example 5, I give you one endpoint and the midpoint. We're calling B the midpoint here. And we need to find the missing endpoint. So our endpoints are actually A and C. And we're looking for B if we're doing example 4, but on example 5, I'm going to give you the midpoint, and one of these two we find the other one. Okay, remember B is your midpoint in this case. So I've given you the midpoint B here. We need to find that other point C on part A. And so here's how we do this. We're going to set up our midpoint equation. Okay, I'm going to say that the midpoint, negative 5, 10 equals x1 plus x2 over 2. And then y1 plus y2 over 2. But I know one of the x values of one of the endpoints, and I know one of the y values of one of the endpoints. Okay, I know that the x value for the first point is negative 8. So I'm going to say negative 5, 10 equals, instead of x1, I'm going to write negative 8 plus x over 2. And for y1, I'm going to write 6. And then I'll just write plus y over 2. So now I've got equations with x and y. And so I can find x and I can find y by setting up these two equations. I know that negative 8 plus x over 2 has to equal negative 5. And I know that 6 plus y over 2 has to equal 10. So I'm just going to solve each of those equations separately. The first thing you should do to each side, though, is multiply by 2. Okay, so let's do x's first. If I multiply by 2, it cancels out the 1/2 and leaves me with -8 plus x equals -10. Then all we have to do is add 8 to both sides, and x, I'm running out of room on my paper, x is -2. Okay, so my coordinates for C, because I know A and B, starts with -2. Alright, now let's find our coordinates for y. We're going to multiply by 2 on both sides again to cancel that 1/2 out. We've got 6 plus y equals 20, and subtract 6, and we get y is 14. So that is the coordinates of my endpoint C. Okay? I want you to try part B and tell me what we get for coordinates for A. In this case, they've given you C, the second set of endpoints, coordinates, and we know the midpoint here. We need to find A. So set it up like we did here, where you can get your two equations and then solve for the x and y coordinates of A. Alright, this is what we should get. Alright, for part B, we get that our other endpoint A has the coordinates -7, 0. And I found that this way. X plus 5 over 2 has to equal that -1, and y plus 6 over 2 has to equal 3. When I solve each of those equations, I get -7 for x and 0 for y. Alright, now, in your lesson, we talked about what a segment bisector was. A segment bisector is any point, line, segment, ray, any of those things that divides a segment into two congruent other segments. The midpoint, then, would be a segment bisector. So we're going to find the measure of QR using a little bit of algebra if I know that Q is the midpoint. If Q is the midpoint, that tells me PQ is congruent to QR, therefore these measures have to be equal. PQ has to equal QR. And then I just plug in what I need to know. PQ is -6a minus 3, and that must equal 4a plus 27. And now all I have to do is solve that equation for a. So why don't you do that on your own? Pause the video to give yourself enough time to do that. And what we should get for a is this. A equals -3. Now, that's not the final answer. We want to find the measure of QR. So we're going to take that and plug it in for that expression for QR, 4a plus 27. So we're going to make it 4 times -3 plus 27. 4 times -3 is -12. And -12 plus 27 is 15. So QR equals 15, and that tells you that PQ is also 15, and the whole thing must be 30 if we were to need to find all that information. Alright, that wraps up all the examples for lesson 1-3 over distance and midpoint. We will go over some other questions in class, and we will start the assignment, but if you'd like to get a head start, it is attached to this Edmodo post also.